Welcome everyone. I hope you all are doing good, right? Great. Here we start an exciting session of robotics using the robotic kit available. And then in the output, we are going to make a simple free running robot using the kit, and then we will learn to make a simple code in KB IDE. Yes, by the end of the session, we will be making a robot which is looking like this. Here you can see that it is a free running robot, and then the motors are attached to it using the RJ11 cables. Here you can see that these are the RJ11 cables connected, and then we are programming this board, and then we will be using this robot to move around. Understood? Yes. So we will learn to make a simple program in KB IDE, and then we will make a robot looking like this. So are you ready for that? Great. So shall we start? Fine, let's start then. Here I am sharing my presentation. I hope you all can see it, right? Great. So these are the things that we are going to make and learn. Here at first we will learn about algorithms and flowcharts, and then block coding concepts, and we will familiarize what is KB IDE software. And then we are going to talk about the coding concepts like setup and loop blocks, input and output blocks, and then delay blocks. And then we will learn how to make a simple program for turning on the LEDs on the board. So there we are using a board, right? So we already talked about it, and it is the brain of the system. And then there we will be having different LEDs which is built in, so we can turn it on. Okay, by using the coding, and by using coding we can turn on the LEDs according to the need. Okay, and then at the final out we are going to make use of the motors. Yes, we are going to interface the motors along with our board, and then at the final output we will be having a free running robot. So that's the thing that we are going to make today. Understood? Great. So shall we start then? Yes, of course, let's start. At first we have to learn what is a programming language, because here we are going to use a programming language. Here we are coding our robot, and then we are using it, right? So we already know that robots are reprogrammable. So we have to know what is a programming language. Here you can see that a man is waving at you, right? And then he's trying to say something. On the right side here you can see it is hi, how are you? And the left side you can see he is saying hola, como estas. It is actually in Spanish. So he is trying to say something in two different languages, right? Here he is saying something. The one is hi, how are you? And the hola, como estas is in Spanish, right? So the hola, como estas is in Spanish, and the hi, how are you is in English. So if you don't know the Spanish language, we don't understand what he's saying, right? Yes. So we all know English, that's why we are understanding this hi, how are you sentence, right? So in the same way, if you want to communicate with each other, or if you want to communicate with the other person, you have to know the language, right? So in the same way, what you can do, you can interact with the machines using programming languages. So we are using programming languages to communicate with machines. So that's what programming language is. Here in the next step we are going to talk about algorithms. Okay, so we are going through the concepts of coding, and then here this is an important step. This is what algorithm. So do you know what is an algorithm? So it is not that hard to understand this algorithm. Algorithm is the step-by-step process. Actually, if you are doing a task, there you will undergo different steps in it, right? So if you want to tie shoes, or if you want to make something, or if you want to cook something, there you have to undergo some certain steps, right? So that's how you can make, or you can complete the process. So by doing step-by-step processes, you can complete the task. So this is what actually an algorithm. Here you can see that there is a mom giving instructions to her child to brush her teeth. You can see that there are 3 steps, and I will read it out. The step 1 is brush your teeth, step 2 is clean brush, step 3 is apply toothpaste. And do you believe that these are in correct order? No, of course, right? Because the step 1 is brush your teeth. It is not like that. You have to clean the brush at first, right? Then we have to apply the toothpaste, and then we can brush our teeth. So these are the steps that needs to be taken, and here 3 steps are used for doing a certain task, which is brushing teeth, right? And likewise, if you are doing multiple tasks, there you can have different steps in it. So each of the steps has its own order. So you should follow the steps in order. So the order of instructions is very important. So we have to do a task. If you have a task, you have to do it, but doing some certain steps, you can achieve the task, right? So that's what called algorithms. Now I hope you all understood what is an algorithm, right? So we talked about programming languages, and then we had a talk about algorithms, right? Now let's see what is next. Flowcharts. So flowcharts are the diagrammatic representation of algorithms. It is very simple. If you want to say something, or if you want to do if you want to achieve a task, you are using algorithms, and then you can, what you can do is you can use the algorithms to make a pictorial representation. So that's what flowcharts. So there we will be using some symbols like oval shape, arrow mark, and the parallelogram. There's a rectangle, diamond shape. These are the things that we are using to implement these flowcharts. So here start and end is there for defining the start and end. We are using this oval shape. So the arrows are used for connection, and then input and output is there. So if you want to input something and there is an output, you can use this parallelogram, and then there is a processing stage, you can use this rectangle, and then so likewise, if you want to make, or if you want to do some certain task, there you have to undergo some certain steps, right? So these steps can be represented in a diagrammatic manner. So that's called flowchart. So I hope you all understood what are programming languages and flowcharts, and also there we talked about algorithms, right? So algorithm is a step-by-step instruction. So algorithm is the step-by-step instructions that we are taking for achieving a task, right? Yes. Now let's talk about what is coding. Actually, coding is the step-by-step instructions that we are providing a computer. So here we are giving instructions to a computer to do a particular task. So that's what coding. We all know about instructions, right? So we are providing instructions to do something, right? So when we are talking about instructions, or when we are talking about a task, there we need instructions to achieve it, right? Step by step process. So just imagine it, you are giving instructions to a computer to do a particular task. So that's what you are doing with coding. Here there are two types of coding mainly: text-based coding and block-based coding. Here in this session, we are talking about block-based coding, and we are using this block-based coding software to program our robot. Understood? Yes. So let's go through what the software look like. Here you can see that this is the KBID software, and it looks like this. I hope you already downloaded it and installed it, right? And now we will make use of this KBID software. So shall we start? Yes, of course, right? So I'll be sharing my screen here. So in here you can see there is a KBID software that I have already downloaded and installed it, and then what you have to do, just double click on it, and then so once you double click on it, it will be opening like this. So we already know how we can install it. So we went through the first session and then we installed it using the link, right? So I hope you can see my screen, right? So this is the interface that we will get once we open this KBID software. Okay, I hope you all got it, right? Great. So in here, these are the tools available. On top you can see that, and then here on the left side you can see different blocks of codes. So when you click onto this display option, there it will be having different blocks in it. Okay, sensor blocks, music block, GPIO blocks. So you must understand that here we are using this GPIO blocks for making the robot move. Okay, and then time, variable, math, logic, and other blocks are there. So we will see what are the blocks that we are going to use and what is the importance of these blocks. Okay, now here at first we will be having two set of blocks here. So one is setup and the other is loop. And what is the difference between these blue? So what are these blocks? So at first we have to know what is a function. So do you know what is a function? So every task that we are doing is a function, right? So even if I'm having a pen, it is having its own function. So if I'm having a pen, it is used to write, right? So it is used to write. So that is the function of that particular object. And in here you can see there are two functions available, which are setup and loop. And these functions are having their own names. The one is setup and the other one is loop. So these are two blocks, these are two functions, and these are doing something. So in here we are using setup function and loop functions. So these are having two names, setup and loop, and these functions are used for different purposes. So at first, when the program starts, we are using this setup function to run once. Yes, how do we know when the program starts? Actually, when you are uploading the code that we are providing here to the robot that we are using, then whenever a power is given to the robot, it will start the program. So whenever it starts the program, it will start from the setup block. And what are all the things inside of this setup block? It will run once. It will run for once. So once the whole things are executed, it will be going into this loop function. So we already know what is a loop, right? It is a continuous process. So there is no end. It will execute the whole things repeatedly, right? So that's what loop function. And then these are the two main functions that we are using. So we can't delete it. So it is already there. And when you start the program, it will be appeared on the screen, or it will be appeared on the block area, and then we can't delete it because it is the main important two functions. Okay, understood? Great. And these are the tools, and serial monitor is there, new file, open file, save file option, just compiling. Compiling is the process of checking the code, and it looks for errors, and it will convert the language into machine language. So that's what compiling. And once we compile, we can compile and run. So it is the uploading tool. So once we compile this code, we can upload it to the robot. So that's why we are using this tool. And then this setup board means we have to set up this board with our software. So how we are going to do that? So we will see how we can do that. Okay. So these are the main interface, and it looks like this. It is simply like we can add the blocks like a drag and drop method. So we can drag it and drop it into the blocks of course. So what and all the things that we are adding should be in these two functions. So you must keep it in your mind that these all should be in these two functions, then only it will work. Understood? So I hope you already opened this software, and now we are going to make use of the LEDs which are built in this board. So I will show you what are the built-in LEDs which are available in this particular board. So let me share the details of this Crino board. Here you can see this is the board that we are using, and these are the GPIO ports. GPIO ports in the sense general purpose input and output. So we all know every computing device has input and output. Like in the case of laptop or computer, we are using input and output devices like mouses, keyboards, monitor, like that. So input devices are the devices which can input data into the system, like keyboards, mouse, etc. So output devices are the devices which are taking data from the computer, like monitor, speaker, like that. So in here we are using this GPIO port to connect external devices to this board. So this is the computing device, and here this you can see that this part is the microcontroller unit. This is the microcontroller unit, and these pins are taken out here, and these are the ports, RJ11 ports, which are available for connecting different sensors and motors. Okay, so here you can see that this is the M1 and M2. M1 and M2, here you can see the label over there. So whenever, so this is the motor 1 and this is the motor 2. Here you can see that, and these motor pins are connected to 25 and 26th pin of this microcontroller, and these motor pins are connected to 19 and 15 of this microcontroller. Okay, so here you can see that it is already denoted over there, And then when it comes to these ports, these are the ports which are used to connect sensors. So you can see that there is S1, S2, S3. There is a port where we can connect ultrasonic sensor. Okay, so in here we can connect one more motor. That's why we are providing it as M3 over there. And this is the overall design of this board, and other parts are related to the supporting elements of this board. And here you can see there is an on-off switch. So this is the on-off switch. So if you want to keep the board working according to the program that we have given, you should turn it on, then only it will work. So there is an on label you can see over there. So you have to keep this switch on the side where the on label is given, then only it will turn on. Okay, now there is a jack, there is a DC jack you can see over there. This is used to connect an external power source to this board. We need an external power source to work this robot, because there we are using two different motors, right? So there we need to use an external power source, then only we can work with this robot. And there is a USB port which is used to, this is a USB port which is used to connect our system or the computer and the robot. So we can program it according to the need. So whatever the things that we are programming, we are using the USB cable to connect this port, and then we will upload it. So that's what this robot. Understood? Great. Now in here we are going to connect this motor RJ11 cables along with these ports. So here what I will do is I will remove these 3 screws and I will show it to you what are the LEDs, built-in LEDs available. Okay, so please let me remove this part. So we have removed the top acrylic shield, and here you can see these are the LED pins. So here these are all connected to the motor pins, which are 25, 26, 19, 15, 32 and 33. So these are the motor pins, M1, M2, M3. You can see over there, right? So here you can see that M1, M2, M3 are there. I hope you all can see it. So these motors are connected to these pins, like, so M1 is connected to 25, 26, M2 is connected to 19, 15, and the M3 is connected to 32 and 33. So these are the pins which are connected. And then actually if you want to use these LEDs, you have to make use of these pins. So we have to control these pins of this microcontroller board to turn on these LEDs or the motors. Understood? Okay, so let me share how we can do that by doing coding. So here we are going to make use of the LED which is connected to 25th pin at first. So we have to program it, and then we have to make a blinking LED program. So let's see how we can do that. Okay, so now we are in this KBIDE software, and now here we are going to program this robot according to our need. So at first we talked about blinking the LED, right? So at first we have to know which is the pin that we are using. So here we are using 25th pin. So there we connected an LED. So we are using this particular LED to blink. So there we need to turn on the LED at first, and then we will program it for blinking LED program. So let's start then. So at first we have to go to this GPIO port. So why we are moving on to this GPIO? GPIO in the sense general purpose input and output. General purpose input and output. So these are the pins that we are using for connecting external devices with our board. So here we are using a 25th pin. So here you can see that at first there is a platform blocks you can see over there, right? There are platform blocks. So on the top you can find set pin 25 as output. So you have to drag it and drop it inside of this setup block. So actually in this setup block we are providing this setup related functions. So here we are setting the pin 25 as output. So why we are using this set pin block here? This pin should act as an output pin, then only a data will be provided at the end, because here the LED is an output device because it needs power, it needs electrical signals to work. So if you want to provide electrical signals to a particular pin, that should be an output pin. So that's why we are providing this 25th pin as output, right? Great. So let's do the next step. We set the pin 25 as output, and then in the next step we need to provide the signal. So what is signal? So here you need to give a positive voltage to the pin. So positive voltage in the sense we have to make the pin high or low. So here you have to go to this GPIO blocks again, and then digital write pin 33 value 1. So here we are using digital write pin block. So digital write pin block is used to make a particular pin high or low. So here we are using digital pins. Digital pin in the sense there will be two states, whether there will be a high voltage or there will be no voltage. So which is indicating 0 and 1. One is indicating for high voltage, there is voltage in it, and 0 for no voltage. Understood? So here digital write pin 33 is there, right? So actually we need to provide the number. What is the number? Pin number that we are using here? The LED connected pin is 25, right? So 25, and we are making it as 1. So once you make it as 1, what will happen? Yes, there will be a voltage in this particular pin. So the LED's positive is connected to this 25th pin. Then whenever it gets a positive voltage to that particular pin, it will turn on. So let's see what happens if we upload the code into the board. So shall we do it? Yes, right? Let's see. So at first we have to know how to connect this robot with our laptop or computer. Okay, so let's see how we are going to connect this one along with our computer. So this is what it looks like, and at first we have to use the adapter. So in the kit we are having an adapter, and there we need to use this adapter. We should connect it to some plug points, and then the other part should be going into this DC jack. So you must ensure that it is going in, and here we can place the switch in off state. Okay, make it off, and this adapter should be connected to this jack. Did you connect it? Please do it. And also make sure that these motor pins are removed. Motor RJ11 pins are removed. So once you've done that, what you can do, you can use your USB cable. So let's take the USB cable. There will be USB A to micro USB cable. So it looks like this, and you have to connect it to your computer. So let's connect it to the computer, and then connect it over there. So here is, you can see that the computer is connected with our Crino board, right? So this is what it looks like. Now in the next step we need to upload the code. So what and all the blocks that we have added right now, it will be now a set of code, and it should be going into this board, right? So for that purpose we have to click on to this compile and run mode. But before that we have to ensure that the setup board has been initiated. Okay, so let's see how we can do that. So once we connected the robot, we have to select the port. So let's see how we can do that. Here you can see at the top there is an option which is called setup board. I hope you all can see it, right? Great. So just click onto that, and then here from the port option, select COM port, you can have a COM port which is enabled. So here in my case it is COM4, so you have to select your own. So there might be changes, like it will be COM4, COM5, COM6, like that it goes. So whatever the COM port which is appearing in the list, you have to choose it. Okay, so make sure that it is the same COM port that we have connected to this robot. In this case it is COM4. Let's select it, and then ensure that it is this baud rate is 115200, and then close. So once you select it, now you can upload the code. In the next step we will see how we can upload the code into the board. So for that we have to click here. So here you can see that to the left of this setup board, you can find compile and run option. So if you click on it, you can see that now it is checking for the board. So here you must ensure that the switch is turned on in your robot. So once you turned on, you can see that now the code is compiling. Once the code is compiled, it will be uploading to the board. Okay, now it's uploading to the board. So once it is uploaded, I will show you the output. So we waited for some time and now the code is uploaded. Now let's see what will be the output. So this is what we will get once we upload the code. Here you can see the LED is now turned on. This is the 25th LED that you can see. So this is the 25th pin and there is an LED connected to it. And here you can see the LED is now turned on and it stays forever. So what if you need to blink the LED? So for blinking the LED, we have to go to the coding part and then we have to make some changes over there. So let's see how we can do that. So let's go to this KBID platform. Then here you can see that there is a digital write pin. We have to duplicate it. Just right click on it, duplicate it, and then put it under this one. So once you've done that, you have to make it as 0. So why we are making it as 0? Because at first we have to make the LED pin as high, because then only we can have the LED turned on, and then the next step we should make it as low, then it will be turned off. That's how we are going to make the blinking LED program. So here you can see that it is now turned on and turned off. In between them we have to add a delay, then only we can see it. Okay, so why we are adding a delay? It is because the programming execution which will be in a fast manner. Okay, it will be very fast that we can't see it. So if you want to see it, you have to put a delay into it, then only we can see it. Okay, so 25th pin is now 1 and in between these two we have to add one time block which is delay 1000 milliseconds. 1000 milliseconds indicates 1 second. 1000 milliseconds are 1 second. So we have to put the same 4 here, duplicate it and put it over there. It is because once this is executed, it will wait for 1 second to execute the next one. Okay, so once it is executed and this step will be executed next, and the LED will turn on for 1 second and the next step will be executed after 1 second, and the LED will be turned off for 1 second, and after that this loop continues, right? So once the 1 second is over, it will turn on again and it goes like this and it will run forever. So that's how it works. So shall we update the code? Yes, so let's upload the code like this. So we have taken this run and compile method. So I will be showing the robot. Now here you can see, now it's uploaded. You can see that this LED is now blinking, right? You can see this LED is now blinking. So this is the 25th LED. Can you see it? Yes. Now let's see what happens if I connect one motor. So this is the left motor that you can see. This left motor is going into the same port like this. So here you can see that it is moving forward, right? It is now moving forward. It is because these LEDs and motors are connected with each other and it is now connected to the 25 and 26th pin. The motor is moving because the 25th pin is now getting a positive voltage for first 1 second and then it will be turned off for 1 second. So that's why it is moving forward and stopping for 1 second, right? So in the same way, what we are going to do is we are going to make use of the other pins. So the other pins are 26, 19, 15. So 25 and 26 pins are used for this motor. So we need 2 pins for each motors. So we will get 25 and 26 pins for this motor and the 19 and 15 pins for this motor. So we will use this motor to work accordingly. So let's turn off this one and then put the next one. So we are attaching the next motor to this end. Okay, so once you add this one, what you can do, you can make use of these two motors. Okay, so here you can see whether if I am turning on this switch, see what happens. It is going backward because here it is getting some garbage values, that's why it is going backwards. And here this is moving like the code that we have provided, it is moving like that. Okay, let's turn off. And now let's come back to this KB IDE platform. Here we can close this one. Now what we can do is we can change the code. Here we are using 25 pin as output. So we already know that we need 4 pins, right? So the 4 pins are 25, 26, 19 and 15. So let's make it as like that. So let's duplicate this one, place it over there, and what you have to change it as 26 because motors are output devices. It needs power to work. So the microcontroller is the board which is giving power to the motors, right? So that's why these are all output devices. So we need to make these pins as output. So 25 and 26 are there. So this is for one motor. And if you want to use the second motor, you have to use the other two pins, 19 and 15. 15. See that? Okay. So did you get it? Understood. Okay. So did you get it? Very good. Now let's remove this one and delete these blocks. Okay. Here you can see that we only have digital write pin 25 on this loop function. So in this loop function, we have only digital write pin 25 value as 1, which is indicating the 25th pin is now getting 1, which is high value. There is a voltage across this 25th pin, right? So we have to duplicate this pin. Let's duplicate it. And now make the second pin as 0 because the motors will work according to the opposite manner, because the motors are having two terminals which does not have any polarities. So there we need to provide opposite voltages. Like if you are providing a positive voltage to one terminal, the other should be in negative voltage. So in the same way, if you are making it as opposite, what you can do is you can make the rotational change. So that's how we can use these motors. Okay, so let's make the 26th pin as low. 26th pin as low by changing the number here. So we are setting as 0. So we changed just opposite to each other. We are using 25th pin as high and 26th pin as low. And now in the same way, what we can do is we can make the 19th pin as high, 15th pin as low. So let's make it as like this. So 19th pin is now high. Let's duplicate once again, add it on the bottom side, 15th pin as low. So once you've done that, we can upload the code. So did you do it? Yes, you did it, right? Great. So let's upload the code by using this compile and run method. Use the tool. So now it is finding the board. We turned it off. That's why it is now looking for the board. Let's switch on the board. Yes, now it's uploading the program, right? Yes. So we will wait for some time. I will show you the robot. Now this is what our robot. See here. Now it is a free running robot, right? Yes, here you can see that it is moving like this. So once we upload it, we can remove this USB cable from this robot, because once the program is uploaded, it stays forever. So it will be on the microcontroller itself. So we can reprogram it, then only it will make the changes. Okay, so let's turn off this one. So we will put this one here. So now we are having our free running robot which is moving forward, right? So what if you need to move backward? So here you can see that we are providing the voltages like 25th as 1, which is indicating high voltage is given, and 26th as 0. Okay, so what we can do is we can make it opposite. So like if you are providing 0 here and 1 here, so let's make it as 1, and here also 0, and here also 1. And if you upload the code, let's see what happens. So I will turn on the switch. So now it found the board, and now the compiling starts. Once the code is compiled, it will upload the code. So now let's see what is the result. So this is our board. It is not uploaded yet. Now it's uploaded, right? So here you can see that it is moving backwards. See? So this is what you will get if you change the code and if you change the polarities. Interesting, right? Great. So did you do the same? So you're having a robot going forward and backward, right? So what if you want to change the directions? So if you want to move left or right, what do you have to do? Yes, I will be sharing with you. Here you can see that. So if you want to move right or left, you have to make the changes to the motors. So how? I will show you. So if you are having a robot like this, if you want to move it towards this right side, what you have to do? You have to rotate this part. The right side motor should be going backwards and this side should be going forward. Then only it will move like this, right? So this is what we are going to make today. Okay, so let's see what happens if we are providing the code just opposite to other. So if I am giving 1 here and 0 here, let's see what happens. See here, the first one is now backward and the second one is now forward. So these are the two motors and we have made the changes like this. So the first motor will be in backward direction and the second motors will be in forward direction. So let's upload the code. Okay, now the code is compiling. We will see what happens. Okay, so I will put it over there. So once the code is uploaded, we will see the result. See, it is rotating in anti-clockwise direction. So it is now turning left. See that? Yes, so this is how we can make the changes to the movements. So now if you want to make the movement a little bit towards the right, what you can do, we can come back to this KB IDE. Then here, what and all the things that you are giving here, you have to change it. You have to give just opposite to another. So make it as 1. Here it should be 0. And this one also should be 0. And this should be 1. Now let's upload the code. Okay, now the code is compiling. So the code is now uploading to the robot. And now once the code is uploaded, you can see that it is now going rightwards, right? Here you can see that it is moving right. So it is making the movements to the right. It is because this side is rotating front side because this is going forward and now this one is going backward. That's why it is going to my right. So this is what happens if you try to give the voltages just opposite to another one. So I hope you all understood the things related to the KB IDE and the blocks. And in here, in the next step, what we are going to do is we are going to use the robot to go forward for 1 second and then it should come back. It should be for 1 second. So for making the movements towards this backward and forward, we are using delay. So here, let's go to this delay option. So go to this delay, time, delay block. You can add it over there. So at first, we have to put this blocks as 1010 in manner. So 25 should be 1, 19 should be 1, others should be in 0, which is indicating this robot is now having a movement towards forward, right? Now let's duplicate this one and put it here. Let's go duplicate the second one and put it here. And again, let's duplicate all together. Again, single by block by block we are duplicating, and the delay block also we are duplicated. So now here we are providing a backward motion, right? So therefore we need to give it as 0, and 26 should be 1, and also 19 should be 0, 15th pin should be 1. Now we have a backward motion for our robot. So what will happen? It will go 1 second forward and 1 second backward. Okay, or else you can make it as 2 seconds. So how we are going to make it as a 2 second? So here I am changing 1 second, 1000 milliseconds to 2000 milliseconds. So then it will be 2 seconds. Let's upload the code. So run and compile tool can be used, and then once it finds the board, you will compile the code and then it will upload the code. Okay, so we'll wait for that. Okay, now it's uploading the code. Now let's see what will be the result. Here you can see that this is our board, this is our robot. So once the code is uploaded, now here you can see that he is going front for 2 seconds and back for 2 seconds. Okay, this is how we are making our free running robot. So I hope you all understood the things related to this Crino board and the movements of these motors, right? Yes. So what are all the things that we have done? So we added different blocks from this GPIO ports, right? So why we are using GPIO ports? Yes, GPIO stands for general purpose input and output, and here we are using these blocks for adding the program that we want for making our robot to work, right? So here set pin is used to set the particular pin as input or output. So if you are giving some signals to the particular pin or some external devices, you have to make it as output. So we are providing all the pins as output. So that's why we are using these motors, right? So here we used different motors, 2 motors here, and LEDs are there, right? So according to the program, the LEDs and motors will work. And here loop, in this loop, what and all the instructions that we are providing, the blocks that we are giving, it will be executed repeatedly, right? Yes. So digital write pin block can be used to make the digital pin as high or low. High in the sense that we are providing a voltage, low in the sense there is no voltage. So it is denoted as 1 for high, 0 for low. So that's the use of these blocks in this KBID. So we familiarized what is KBID, and we used to know how we can set up the board using the setup tool, and we used we selected the COM port from the list, and then we compiled the code, and then we uploaded the code using compile and run tool. So I hope you all understood the things related to today's session, right? Great. So we learned about what is algorithm, flowcharts, and block coding concepts. There we are using KBID software, right? So we used to set up loop blocks, input and output blocks, right? So then at the final out, we have used these motors to move around. So we made a free running robot by programming our robot using KBID software, right? Yes. So I hope you all enjoyed and understood the things related to today's topic. Thank you for your participation. We will see next time. Bye.